Orkun, how are you today, my man?
I'm doing pretty well, and I'm so excited to be here. Uh, we have lots of topics to talk. I can't wait to start. How
Love
are you
it.
doing?
I love it. I am fantastic. Also very excited. You guys have been dropping some like mysterious-ish alpha on Twitter. Not diluting everything, but dropping some alpha about what you guys have been building. Looks like you might have solved some very big problems around rollups, the pegging process, utilizing BitVM in some way, which
hmm
is like what 4 months old at this point, maybe less than that. Like this is still very new bleeding edge tech. So a lot to cover, that is to say. But I guess broadly, let's just kind of start easy. And I'd love to get to know a little bit about your background and kind of how you ended up building on Bitcoin.
that will be a good start. I'm also like CEO of ZK Rollups, but I'm an engineering background person. So I worked as developer for years. Initially, I did like developments on some EVM chains. I was smart contract developer. Then in the meanwhile, I was like playing around with UTXOs and building like some mock blockchains with UTXOs. Then after some point, I got interested more in Bitcoin. And early this year, actually, as a company, we built Ordinals Safe. The first one of the first extension was on Ordinals, and it was like quite fantastic for us because we launched the product in a month, and it got like a lot of users, and Ordinals was really hype, and it was an exciting process for us, and we dig deeper on Taproot and script. So in a quick time, we got really expertise on the Taproot side. And after that point, we also previously developed zero knowledge proof systems on EVM chain. For example, we developed proof of innocence, which is a privacy tool on EVM chains. And after that point, we knew that, okay, we know ZK well, we know Bitcoin script well. What if we can combine this knowledge and bring DeFi on Bitcoin? So this is like an igniting story for Chainware Labs and also Citrea.
Got it. And on that topic, could you place us like when were you building on ETH, and then when did you start to like transition over? Because it's a trend I've seen some people do. They kind of like either left 2017 or they left last bull run and jumped over. So I'm curious, like, can you place us time wise?
Like as a regular job, I think we were on EVM ecosystem in general until I like 2 year ago or ETH ecosystem much more. But we were also interested in UTXO side, especially playing around UTXOs, building interesting scripts and interesting span paths. And meanwhile, like I said, we discovered. Okay, we were talking about modularity rollups, and we talked about okay, there's a UTXO based system. There's not no accounts or no contracts. What if like we can embed data, embed the rollup data for these? We already know like colored coins and RGB and stuff, but we want to do something more expressible. We started with that idea, then Casey invented Ordinals basically. So in scriptures, we know that it was already possible, but we haven't explored any paths before Ord is actually came out. And after the Ordinals came out, we realized, okay, there's an easy way to do it, and we can use this for DeFi and stuff. After building Ordinals Safe, we immediately focused on this, left the research part, and actually started building.
Got it. Um, Perfect. Then I think that's a pretty good segue to start to jump into like rollups broadly, because this is a topic that it's been, in ETH, you guys it's much further ahead, it seems like, when it comes to the tech side. Um, and John Light put out a paper maybe a year ago that was like pretty well known as far as like the bleeding edge of what rollups could look like on Bitcoin, but it always felt far away, mainly because the opcode issue of like you need to have like op stark or something. Um, and so, like, a lot of the conversation was around L2s or around um, covenants, for example. Like, right now, we're talking about CTV and we're talking about sandwiches and stuff. But rollups are still kind of like further down, unless you solve the peg and process a different way, it sounds like, or a verification a different process. So, before we jump into the specific, how you guys are building it, can you, because people know these terms, rollups, optimistic, sovereign, but most of us don't really know what that means. So could you give us like a brief overview of kind of like the landscape of what is a rollup and like what does it look like on Bitcoin?
Sure. Rollup is actually, I prefer to call them execution shards because eventually rollups are the only trustless construction of L2s in a universal manner. So we have like Lightning, and it is a peer-to-peer because so that it is trustless. You are only trusting yourself. But in universal systems that have global state, for example, that is mostly programmable chains. Like think about Liquid, think about Stacks, think about Rootstock. These are universal systems, and these systems is not trust. You are moving away from Bitcoin, trusting another entity like stake miners, rootstock signers, or merge miners and stuff. These are not trustless solutions, but rollups in I think 2018 they emerged as the trustless and universal solutions, and it actually stems from one single and most important thing. They use Bitcoin block space. They don't create another block space, or they are not moving to off-chain and do some things there. They move off-chain, but they only compute off-chain, then go back to on-chain with a proof. This is either a ZK proof or fraud proof. And they embed the data on-chain so that you can unilaterally exit and use this data to construct the state. Basically, rollups are like only trustless universal L2s that can be built. And on Bitcoin context, so far we couldn't aware of any construction that can be trustlessly built on Bitcoin. There are sovereign rollups, like you said. They are basically using Bitcoin to embed some data and depend on client-side validation, just like RGB and other client-side validated protocols, like on Ordinals also. But this fell short in something. They don't have native bridge to peg in and peg out BTC. Sovereign rollups don't have bridge. They are just using Bitcoin as DA and consensus. Bitcoin doesn't aware of anything happens on the rollup, so you cannot peg in, peg out trustlessly or trust minimized. These were the problems. And initially, once we started Citrea, we were building a sovereign rollup and thinking about solving the peg problem in some other way, which is now abandoned. But later 2023, Robin invented BitVM. I think this is most important thing in Bitcoin space right now for maybe 2 or 3 years, because it basically allows us to build smart contracts in a trust minimized way. I just saw your tweet you hate the word trust minimized, but it is not trustless because not every participant, not every Bitcoin node verifies the script. But if something happens, they are verifying it. So it is not a client-side validation, or it is not native. It is validated inside the Bitcoin if something goes wrong. This is an efficiency problem. BitVM is efficient and make it possible to build true and complete contracts by doing optimistic way. In a fully pessimistic way, which means every script gets executed on Bitcoin, it won't be possible. So BitVM is invented that way. Then after that point, we realized that, okay, we can use BitVM's properties to make the peg in, peg out, which is a settlement process, easier. And this is now where we are talking about ZK rollups and optimistic rollups, thanks to BitVM. If we need to go further, we need to introduce several opcodes to make them fully trustless, which we can still talk about at the end of the recording. But currently, BitVM provides us a trust minimized way to build these rollups on Bitcoin.
Got it. Okay, we covered a lot there. I'm going to try and rehash a little bit of it to make sure that we're going in kind of eyes wide open. So that one thing you said is that rollups, ideally, they give you a trustless environment, and they batch things. You mentioned this word execution shards, and I think this is something that most people that aren't super technical don't fully grasp, myself included, around what does execution mean when it comes to global state and blockchains versus storing state of data availability, or what is true. So I just want to make sure when it comes to this execution shard piece that you mentioned, is that really important to understand what a rollup is? And if so, can you just double click on it a little further to make sure that we grok it properly?
Yeah, maybe I can give some examples on Bitcoin network and ordinals. So in Bitcoin, regular payment transactions, both settle on Bitcoin, right? All the nodes agree on the same state, so they settle on Bitcoin. And all the data is published on Bitcoin network, so all the nodes have the same transactional data. So this is also data availability itself for the L1. And also for the execution, all the nodes execute transactions one by one. So they know that these transactions are valid and they execute it themselves. And think about Ordinals. They use Bitcoin as data, like their script starts with op false, right? It says that don't execute this branch. So the data embedded with Ordinals don't get executed on Bitcoin because they are not programs or scripts. They are just a bunch of data. So in Bitcoin core node, these data is only used for data availability, but the execution happens off-chain. You are running an Ord node, which is basically a meta protocol that looks to Bitcoin, extracts the data from Bitcoin, and make it meaningful. Like concatenates all the bytes and it says, okay, this is this JPEG, this is this HTML. It settles on its node. And also it's like executes these things, for example, recursive inscriptions. It recursively like executes these scripts off chain. The recursion is not happening on chain. Only data is put on chain. This is like something unique to meta protocols. They both settle and execute off chain, but the data is held in Bitcoin. In rollups, this is also pretty similar. In native rollups, I'm talking about ZK and optimistic rollups. You are using Bitcoin as data availability layer, which means all the data sits on Bitcoin network, and settlement also happens on Bitcoin network. Right now, it is through BitVM, and in the future, it can be like OpZKP or OpT-Stark, any other opcode that can settle the transactions. So all nodes can be aware of, but the execution happens off-chain. Bitcoin doesn't know about these transactions. For example, we are building a ZK EVM, which is an Ethereum virtual machine implementation running on Bitcoin. But Bitcoin doesn't actually run Ethereum virtual machine. It's just like we are just creating a batch of transactions and run them in like ZK virtual machine so that we have a ZK proof. We created an execution shard actually. We sharded execution from Bitcoin base layer to some other components, which is Citrea. Then we compressed all the transaction in a verifiable way and put the data back into Bitcoin. So Bitcoin don't offload it with, unload it with all the bunch of execution. We use Bitcoin efficiently by just using it for settlement and data availability layer. And we are doing execution on Citrea.
Got it. Okay. And then just to make sure I kind of understand this, one of the differences with a regular L2 sidechain is that once you peg out, Bitcoin has no idea what's going on there, and the data availability is also on that sidechain. So it's like a fully enclosed system versus rollups that kind of have this synergy between the base layer and the rollup, right?
Yes. So sidechains, like I said, once imagine that you are moving to a sidechain, you usually like use some kind of pegging process like multisig, right? You are depositing your BTC to some multisig, then you go to a sidechain. And imagine that this sidechain is merge mined. So in this sidechain, if miners and majority of nodes are like dishonest, they can steal your money. And if the bridge nodes, bridge signers are dishonest, they can steal your money. Or they can just withhold the data from you, just like block your IP address so that you cannot access the data. You cannot get the data anywhere, so that you cannot even request an exit. Even though you request an exit, they can just prevent you from exit. This is the like unsecure things about sidechains. But in the rollup case, all the data is also on the Bitcoin network, and Bitcoin is censorship resistant. Just create a Bitcoin core node, then you have all the rollup data so that you can use this to exit unilaterally. In the BitVM, not unilaterally, you need the help from one verifier among all the community. It is like an honest minority assumption, but in the trustless scenario, you just need a Bitcoin core node to do all the transactions and exit unilaterally. This is what makes rollups different than sidechains, actually. It is all about security and efficiency.
Yep. Okay. That makes sense. So the biggest issue here really is the assurances you have really getting your Bitcoin back off that sidechain. Because for the most part, like we've had proof of burn forever where you can just send your coins one way, do a bunch of fancy stuff, and it's kind of stuck. But it's having the assurance that whenever you need to, a minimum amount of people as possible. This is like the term trust minimized, which, as I said, like the problem is that it means so many things. There's a wide design space of what trust minimized means, but it's a useful word between custodial and trustless, where you can for sure get your coins back. So that's helpful. I think then we have a pretty good base foundation. I'd love to start to deep dive into like what you guys are. I guess this will come out after you guys have officially announced. So what you guys have launched officially, what you guys have been cooking up. Uh, what is Citrea, and then we can kind of dance around different topics within that.
Yes, like Citrea is the first rollup on Bitcoin that enhances the capabilities of Bitcoin block space using zero knowledge technology. Why we are using like this term, enhancing the capabilities of Bitcoin block space? Because Citrea is not some off-chain solution like sidechains. Citrea actually works on Bitcoin block space and like process lots of transactions, maybe like 10 times even higher than Bitcoin or 100 times higher than Bitcoin, and batch them together and submits them to the Bitcoin blockchain again. So everything lives in Bitcoin blockchain. And this helps Citrea to assure that we have Bitcoin equivalent security, Bitcoin equivalent data availability, and Bitcoin equivalent censorship resistance. This is something important that we targeted at the beginning, and this is something why we are building Citrea. We believe that like Bitcoin is the chain that you can get censorship resistance, that you can get all the security guarantees. And if you build something else than Citrea, than ZK Rollup, then we just leave these things behind and create a new ecosystem that has own security guarantees. We don't want that. So we are expanding the capabilities of Bitcoin block space. You can now do Turing complete smart contracts through EVM. You can build anything. You can build a DEX. You can build a other fungible token standard. You can build non-fungible token standards. You can build anything within this EVM shard. But the security is also Bitcoin level. And the capability throughout is also above the Bitcoin level. So we are enhancing all the things that we can do, like programmability and true output, but we are keeping security as Bitcoin equivalent level.
Yep. Okay, makes sense. And what is the big unlock here? Because I think we've had EVM, base chains try something to make Bitcoin more extendable, like a smart contract platform. And ZK is like becoming more mature on ETH. So is BitVM like the piece that was it the missing piece of the puzzle that like unlocked most of this?
I would say it was a team that can both build zero knowledge technology, and Bitcoin was a missing piece. It was one of the important things I need to like give a credit to all my teammates there. I think in Turkey it's like 8 p.m. right now, and our office is full. My co-founders and my teammates are working hard. So I need to give them credit, Murat, Ekrem, and Esat. But the biggest unlock, like you said, for the peg in, peg out process, which is the actual settlement, the biggest unlock is always the BitVM. And on top of that, the technology that we are using, which is recursive ZK proofs, that allows us to build BitVM program in an efficient manner. We are using Bitcoin block space efficiently, and we need to use BitVM efficiently because it is not like something. It is not something perfect. It is pretty good innovation. I think the biggest innovation on Bitcoin right now, but it is not perfect. So it has all limitations. And with our technology, we are trying to make the process as efficient as possible. This is the biggest unlock. And going further, the BitVM makes us trust minimized, makes the ZK Rollups trust minimized. But in the future, we believe that there will be some opcode that can verify ZKPs directly on the Bitcoin script. So we will get trustless and unilateral rollups on Bitcoin. This is also like not something for only rollups, but we are talking about a VIP process for every single opcode, right? You need to like do some functionality, you need to introduce a VIP. But if you have some generic ZKP verifier on the Bitcoin base layer, you can implement any opcode with ZK circuits. And Bitcoin doesn't need to aware of the fact there can be those. There is a need for these opcode because it is already embedded. Everything is embedded in the ZK. I think the biggest unlock is BitVM, but the target is always have a Bitcoin, ZK native Bitcoin base layer.
Yep, makes sense. We're all hoping for that opcode to come sooner than later, so we can get that trustless nature. Until then, what is so you're saying it's trust minimized to be like fully accurate. What is the trust assumption here then? Like if I'm going to use Citrea, where what party in this kind of stack am I trusting with my BTC on? I'm guessing it's the peg up process.
There are two components that you need to trust in Bitcoin L2s. One is the peg in peg out process, and the other is the nature of the L2. Let's give an example from rootstock, because it's a perfect example to have an understanding on that. You are risking, you are taking risk of two things in rootstock, right? One is the 9 signers on the Bitcoin main chain that held all the Bitcoin in a multisig. This is the one security assumption, and the other security assumption is rootstock network is actually secure. They have enough hash power. They have enough honest nodes that can put your money in secure, and there is no reorgs to miners and stuff. You are getting two security assumptions on that. On ZK Rollups, the block producing and node part is trustless, because thanks to ZK proofs, all these block producing process and transaction process creates a validity proof, asserting the correctness of the process, so that you don't need to trust anyone, any node, any block producer. You just get a mathematical proof and you are verifying it so that this is correct. On that side, you are not taking any trust assumption. But on breach side, you are taking assumption of BitVM, which is one of them. We call it honest minority assumption. For example, in regular multisigs, for example, in 9 signer, if you have 5 malicious signer, they can steal the money, right? It is 5 of 9 actually. But if you have 9 verifiers in BitVM, the money can only get stolen if 9 of them are dishonest also. This is something much more secure than 5 of 9, because if at least one of these persons are honest, then the money is secure. And also you don't have liveness either, because of BitVM's reveal nature. You can just do a series of challenge response transactions and reveal the data needed. So if you are correct, you can exit. Operator can help you to exit. Any party can help you to exit. And if only one of the verifiers are honest, then your money is fully secure. So I can tell this is the most secure L2 construction that you can right now do with a universal stake, unlike Lightning and client-side validated protocols which don't have BTC.
Got it. Okay. No, that makes sense. Yeah, and on the ZK proof side, I just want to make sure that everyone understands, and I think I get it, which is that what you mean by ZK proof is that you have, so we know about cryptography, which is this very advanced but verifiable mathematics that when you put it through these algorithms or these hashing functions, that you get, depending, if the input is the same, the output is the same, and then you can verify this equals this. And as you get more complex with a ZK proof, you can confirm without knowing the parties involved that this happened and it outputted this. And it sounds like with personal verification, like running a light client, you can verify that yourself. So your computer, for example, can verify that state based on the proof that it got. And the honest minority is that as long as you have that one proof, you can challenge all the other dishonest actors, and it runs through that tree of mathematics, cryptography, and gets to, no, 10 people are wrong because I have this proof here that's mathematical. Is that like a layman's way of putting it?
Yes, definitely. You can think ZK proofs as a black box. And once set up in goes rollup, we are agreeing on that, okay, this is a black box and the label of it is A. So if you just verify the proof using this A label, then you will get true or false. If the proof is correctly, get all these black box circuits inside of the black box, you will get true. If it misses any of the branches on circuit, or just going around the black box and producing a fake proof, then the function has to return false. This is the nature of ZK proofs. And in BitVM, we are embedding this ZK proofs in the BitVM program, so that what happens is basically you are operator just provides a ZK proof saying that this proof is the correct proof. And if all the verifiers can agree by just verifying the proof against the label that they previously agreed on, then everything is good. And if one of them thinks that, okay, operator provides me a false proof, which returns false in my function, then they can provide a correct proof and slash the operator and replace the operator so that they can help users to exit the system. This is how validity ZK proofs works in collaboration with BitVM.
Got it. That makes sense. So on the side of who's verifying these, it seems like up to this point, most of it has been economic-based incentives to make these things work. So you have like miners who have an incentive to get, the fee structure, where you have stacks, which is also like a similar, they get a token and signers lock up their thing. So most of them have been economic incentives, and that's who you're putting your trust in. When it comes to, like, if we're going to identify who are the verifiers here, and again, honest minority, like as long as you have one honest person, you're good. But like, I guess the first question is like, how do you become a verifier? Like, what does this process look like? Like, can we each do it ourselves? Are you staking anything? Like, help me understand, how are individuals securing this and like becoming verifiers?
Mm-hmm. In the current BitVM construction, the verifier set is static, which means that you cannot just go to the set and exit the set at any time. It is set one time and continue the lifetime for the rollup. And they stake some BTC in the BitVM program, so that if they challenge something wrong, they get the BTC of operator. And if they just spam the operator by false proofs, and then their BTC gets slashed. So they have a minimal economic security. But for example, in stacks model, you need to have like STX collateral, the SBTC model. You need to have like STX collateral on the stacks chain, which always must be bigger than SBTC's dollar value. Because if it goes down, then this is crypto economically not secure. But in BitVM, the staking amount is not a function of the bridge amount. It is some static amount that you need to stake because everything is cryptographically asserted. You don't need to put high collaterals. If you just wrong, your stake is gone no matter what is the bridge amount, because your wrongness or correctness can be proved in the BitVM. So that in the beginning, it's a fixed set of verifiers with like minimal crypto economic value, because it doesn't depend on crypto economic security, but it depends on cryptographic security. And in the future, if we have some kind of covenant, which is, I'm not into like the technical details of all of that, you can have a dynamic set of verifiers, which means if you are not happy with the situation, you can join the BitVM program and challenge the operator, so that it is permissionless system. And hopefully in the much better future, once we have like ZKP verifiers on the Bitcoin base layer, then the process is already trustless. You don't need to have fraud proofs or against proofs to some operator.
I see. That's super interesting. Okay, so like, as you mentioned, like when it's pure economics, you have to have the TVL and the locked economic security are kind of in tension. And this could be like a hash rate majority if it's merge mining, or this could be, I think with the new SBTC model, it's something like 70%, which is, a lot, but still it's based on economics. And as that tension rises, if SBTC gets really popular, then there's more incentive to steal if you hold enough stacks. What you're saying is that you hold enough to make it painful to cheat or lie, but it's super easy to prove that they were wrong. So the incentive is so much lower because you can be called out super easy by just putting one person in that stack, putting up a fraud proof. You absolve yourself of your BTC, which is like your collateral, and do you get kicked out from the verifiers at that point? And again, like you say, it's static. So I'm curious, like, how often are these being spun up, and how do new people join if it is static once it's set at that point in time?
Mm-hmm. So, like, BitVM is actually, like I said, n-of-n multisig that works on minority assumption. So if you need to change the set, if n-of-n verifiers can agree, they can immediately change the set and set up a new BitVM program. If everything has a good intention, so you know that, so you can just sign the transaction and make a new committee. But if you believe that there is some shady things going on, if one verifier is present in the signature committee, they can just prevent their signature so that the change wouldn't be happen. And I believe like our checkpoints is in every 6 months or so, so that you can change the verifier committee in every 6 months if needed. But like you said, automatically they get out of the committee if they do something wrong, because their slash is gone and they cannot no more be present in the signature thing, and also like they cannot put another fraud proof, or they cannot defend themselves because they are already kicked out if they do something wrong.
Got it. Okay. Trying to think, because you mentioned this 6-month thing before, and this is something when I talked to Paul Storr from Drive Chains, and they have this like this. It sounds similar. I'm sure it's very different, but like this acting process of like 3 to 6 months. So when you say 6 months, do you mean it's happening twice a year, or is it like the checkpoint is 6 months, but it's happening kind of periodically in a chain, and so you can only backdate to like, I guess, what is like ultimate finality or challenge 6 months past, but it's consistently happening? Like, help me understand that nuance there.
Yeah, settlements, like the actual verification on BitVM, happens in every 6 months, but this doesn't mean that withdrawals are happening in every 6 months. If everything is good, meaning everything is optimistic, the operator already like front covers the liquidity for withdrawals. Then after 6 months, it like claims all the front covered liquidity from the BitVM program, so that withdrawals are immediate once the proof is finalized on Bitcoin, but the claim process by operator happens later. As the like BitVM is one of and not trustless, you always need some party to like collaborate. You cannot unilaterally exit without OPZ, KP, some kind of opcode. This is why like you need to front cover. If operator rejects the front cover, these transactions, at the end of 6 months, they got kicked out from the committee, and the honest verifier replaces the operator, so it can help you to exit by front covering your liquidity and claim the money 6 months after that. So 6 months is the actual settlement time. This is because of like the inefficiency of BitVM. You cannot just settle in every single block because it takes too long if there's a fraud proof. And like you are moving all the UTXOs, it also costs lots of money on BTC. But this is something that can both increase the UX on optimistic case and also protects people in the pessimistic case.
Got it. Okay. And is there any issue with reorgs here? Like, obviously 6 months sounds like a long time when you first hear it. So is there issues with like something happens over that time period? There's like that's a big window of reorging if that was to happen. So like, what's the mitigation, or is that an issue?
Yeah, in 6 months, like the reorgs cannot affect the 6 month period. But once the fraud proof process, the challenge response process, if it starts, then reorg is an issue. But in the BitVM, we have like enough time span between these challenge responses so that reorgs are not issue.
Got it. And then on the challenge side, what does that look like? I've heard it's like, is it sending transactions on Bitcoin with some kind of like piece of the proof? And it sounds like I've heard it's pretty inefficient. So I'm just curious about this topic of how does the challenge process work?
Yeah, the BitVM was actually like the name of the paradigm, the computing paradigm that is that tells about this process. But later it renamed as like the actual name of the VM. So Robin and his team is right now building a BitVM, and it works like a generic computer that can run any process up to like 4 billion cycles. And in the worst case, you have 40 Bitcoin transactions to like prove something is wrong or right. For example, I'm an operator. I put an aggregated ZK proof saying that, okay, this was all the aggregated proofs, and this is the withdrawals. I did them all. This is the proof of that. And if you are not agreeing with me, you are like putting a 1 Bitcoin transaction and saying that to me, okay, reveal this template branch. And I'm revealing it, then you are responding it. And I'm revealing, you are responding. At the end of the 40th transaction, the truth is coming out. If I'm either true or false, and if I'm true, your stake is gone. If I'm false, my stake is gone. This is basically how it happens. A 40 transaction may look a lot, but it is pretty efficient to make all this process. Trust me, my smart contracts on Bitcoin uses 40 transaction. It is good.
Got it. Okay. I mean, this sounds, just the piece between the economic kind of like collateral put up and the cryptography. It sounds like a really deadly combo to solve a really big pain point. So really, really excited about that. So we've seen a few people recently try and raise on ZK Rollup Tech, and they have a token. So they're raising on that token. It's a gas token. Who you stake it? Who knows? They do fancy stuff. Do you guys have a token? And like, who gets who gets fees on the rollup? I'm assuming it's denominated BTC, but like, yeah, is there a token, and how does that dance down?
We don't have a token. The BTC is our native token. It is just renamed as like CBTC, Citrea BTC, to make the process easier. But we don't have any Citrea token or such. Like there will be lots of scams and hopefully not. But there is no Citrea token. We are using BTC as native token. This is like all process of BitVM. I don't like to talk about like the other project, but I can go through like fee question. So basically, fees go to Bitcoin miners. This is the whole point of like using Bitcoin block space. So we are collecting fees on the rollup on Citrea. Then we are paying like 99% of the fees to Bitcoin miners because we are inscribing a bunch of data to Bitcoin network. And also like this includes ZK proofs and compressed transaction data, some other transaction metadata that we need to put. We are putting all of them to a Bitcoin block. So we are paying lots of fees to Bitcoin miners. This is an important point. Thank you for asking that. Also, like the pain point of the sidechain and L2 thing, Bitcoin, like we are pretty close to halving, and like fees we believe that needs to go higher, but it also needs to be some kind of accessible to everyone. So the Rollups is also like solving this point because they are paying lots of fees to Bitcoin and they are making transactions cheap for users because they are batching all the transactions. This is why like Citrea also contributes Bitcoin's long-term health by just like paying lots of fees to miners and increasing the hash rate and increasing the security and so on. And on the fee side, like I said, most of the fees obviously go to Bitcoin miners because we have to inscribe the transaction data and we have to pay for that. And the rest of the transaction data will go to prover, which produces the ZK proof, and it is not an easy job. We are running like really huge machines, and this goes to that. And at some point, the sequencer and prover will get multi. So we will have lots of sequencers that works in coordination, and we will have prover, which is a permissionless that anyone can produce a proof. And after that point, the remaining fees that we collected and inscribed to Bitcoin, the minus between them will be shared among these sequencers and provers.
Got it. Okay. So the majority goes to miners, a small subset goes to verifiers, which again, as we mentioned, provers. They lock up a small amount because of this kind of like dance of cryptography and economic collateral put up front. And if there's a bunch of economic activity happening on the rollup, the nice thing about this is because of the way it bundles down, you don't have to send a bunch of transactions like we've seen with, BRC20 mints. We get 10,000 mints trying to, do some ticker symbol and spam the mempool, as people will say, which in aggregate is a lot of fees. But in a rollup, you can do that on the rollup, and it condenses down to one clean, fat fee, which makes everything else easier on the L1. So that's really, really nice to hear.
One example is that, sorry for interrupting, we are using state diffs, the architecture, and it means that we are only writing the storage difference between the previous state and the latest state to Bitcoin. So imagine that you have a decentralized exchange and you are swapping USDT to BTC. And if 100 people swaps on the pool, then the data inscribed on Bitcoin is just the initial data and the latest data. The intermediate data is not get written into Bitcoin because it is already proven in the ZK circuit. You don't need to put all the unnecessary data. So this makes the rollups and Citrea much more efficient than BRC20s and the other meta protocols that run on Bitcoin natively.
Very nice, very nice. Okay, so when it comes to building, this is a big topic because, especially when you look at the L2s, the L1 has Bitcoin script, which is notoriously kind of a pain in the butt to learn. And then the L2 are trying to make it easier, and you have EVM on rootstock, and I think simplicity is what they're trying to do on Liquid, and Stacks has clarity. So this is EVM based, so is anybody who's building on Solidity can basically just easily port their DeFi application or whatever over to Citrea, and it's roughly a copy and paste with maybe changing some parameters or some network stuff. What's the developer experience like if you're building on this?
Yeah, the goal for us is make every app a Bitcoin app. this is the goal for Citrea. We want to like make Bitcoin the foundation for world's finance, and we need to have like all the financial apps built on Bitcoin. And right now we are seeing that like all the DeFi activity happening on EVM chains, mainly driven by Ethereum, and we are building an like EVM equivalent ZK Rollup on in Citrea, so that everyone can copy their apps from Ethereum and move to Bitcoin and make it a Bitcoin app. It will be like Bitcoin equivalent security, but it will be the same developer experience, so that you don't need to port stuff, learn a new language and stuff. There will be like several different parameters like gas limit and stuff, but this doesn't affect the solidity or the code that you write, but some deploy parameters, I can say. You just need to tweak something, changing the RPC URL and stuff, but this is not like some big deal that you can do by deploying this. You are just copying the code, pasting it, change a parameter and deploying it. This is as easy as possible to make every app a Bitcoin app. And the solidity experience is also good, but we built Citrea in a way that we can introduce new virtual machines in the future. Citrea is like, the code itself is pretty modular, so we can plug in any VM if it is in ZK Rollup. And for example, we can port a WebAssembly VM into the stack, and every Rust developer in the world now can develop a Bitcoin application. This is a future plan, not something prioritized first, but this definitely enables lots of builders to build on Bitcoin.
Got it. Very exciting. I'm curious, for like a lot of my audience is somewhat newer. Some of them want to become developers. I'm curious in your experience, like, we're in early 2024, and you have things like EVM rollups coming online. And you're like, what would you recommend people do right now? Is it really, does it help to really learn Bitcoin script if these like expansive L2s are coming? Would you learn Solidity? Like any general advice I'd be curious about.
I would say like right now Bitcoin script has some apps that is also like user facing, the multi-sigs like this, some storage solutions like BitVM, but most of the applications will be on L2s like Citrea mainly. So if you want to like develop some, let's say, user facing applications, then going with Solidity and deploying on Citrea is the best way that you can do. But for example, if you want to work with Bitcoin scripts, BitVM, you want to do an infrastructure layer for the L2s and the other applications, then Bitcoin script is also a good way. I don't like want to pull everyone to Solidity. Then I want like lots of Bitcoin script developers, and I also need Bitcoin script developers to work side by side. But if you want to like have some user-facing applications, come build on Citrea, because like there will be lots of liquidity, there will be lots of developer support, so that you can deploy your applications easily and start welcoming users. But if you want to build some infrastructure, then I think Bitcoin script. Also, if you want like build something natively on Bitcoin, for example, like they did some tricks with OPCat, the Taproot wizards. They did some cool scripts like emulate covenants and stuff. If you like it, I fully support learning Bitcoin script. But most of the user-facing things will happen on Citrea.
Perfect answer. And ultimately, we need 100x more developers across the board on everything Bitcoin, because there's just so much to build. So cool. I appreciate that. Well, this has been great. We covered an absolute ton. Super excited. I'm out. Just the idea of like minimal collateral and this cryptography for like the peg and verifier process seems like such a big unlock. So very excited to see that out in the wild. I guess last two questions. First one, when can we use this? When is this going to launch? Where's the product at currently?
Yeah, so we are recording this pre-launch, but hopefully in the February we launch the technical specs so that you can learn all the internals of Citrea, how it works and stuff. And you can also like start learning Solidity, start developing applications. And hopefully in the April we will have a public testnet, so you can deploy your applications, use Citrea. And this is the like general flow looks like. We have like lots of upcoming announcements, the partnerships that we already did before launching the product even. So in the April, we will have a public test that people can deploy, people can use. But right now, you can just join the community. We will have a big Discord that people talk and ask questions. We will have a like developer town house, and we will have a documentation section that you can visit anytime and gain up-to-date information about Citrea.
Awesome. Sounds good. And I'll have all those links down below as well. Then yeah, I guess last question is there anything that I didn't ask? Like any closing thoughts or things you want to cover that we didn't cover so far?
I think like on the technical side and user flow side, we covered a lots of things. But I need to like say that we are building Citrea to have like Bitcoin equivalent secure and true incomplete and easy developer UX infrastructure for everyone to build on Bitcoin and use Bitcoin. With like this EVM base with Bitcoin security, you can build private L3s, you can do private Bitcoin swaps, you can do private sands, you can even like put a better version of Lightning on Citrea and it will work flawlessly rather than like dealing all with on-chain stuff on Lightning. You are just putting it on Citrea. It has like trust minimized BTC naturally coming from Citrea, and you are using it on your payment solution. I think like the future will be on like building on Citrea, building on Bitcoin equivalent secure and true incomplete layer that can provide all the things that you need. And like if you have like some applications or want to deploy Citrea and fully open, and my DMs are open, and you can like reach out to me for every channel. We have a big developer team, we have a big business development team. We can always support you.
Awesome. I think your DMs are going to get flooded very soon, so prepare yourself.
No worries. I just love developers as a developer.
Love it. Well, man, Orkun, thank you for doing this. This has been a fascinating conversation. Very excited to jump in Discord and see what's going on in there and try this as it launches. So yeah, excited to try Citrea, and thanks again for coming on the show.
Yeah, like thank you for having me and like asking these key questions that everyone can ask and everyone can understand. Thank you for doing this.
Absolutely. And for everyone, all the links for everything we mentioned will be down below. But until next time, thank you for listening this far into the episode. If you found it enjoyable, please do like, subscribe on whatever platform that you're listening on. YouTube does me a huge favor to like and subscribe. Find me on Twitter at Jake Blockchain. Show me some love. I reply to every DM. And if you are a Bitcoin builder that is kind of at this forefront of building new use cases, whether it's L1, Lightning, Stacks, Rootstock, Rollups, Ordinals, BRC20, I want to talk to you. So when I'm not doing this podcast, I am the sourcing partner at the Bitcoin Frontier Fund, where we invest in Bitcoin startups at the earliest stages, give you access to whatever you need, whether it's legal, product, fundraising help, as well as capital. So love to talk to you. You can hit me up. Again, find me on Twitter at Jake Blockchain and shoot me a DM. I'll read everything. Love to talk to you guys. All right, peace.
Welcome to Built on Bitcoin.
I know that things don't always go your way, but I'll be right here.